Hey everybody, welcome back to Graphing Exponential Functions, Part 2. In the first part, we graphed two exponential functions, listed the key features, and talked about how to solve for various things, either visually or using some skills that we have acquired over this unit for exponential and logarithmic functions. So let's keep going. Again, grab your writing utensils, something to write on, such as graph paper or a notebook. Hint, hint, grab your notebooks. And also a calculator. You might just need it. And let's jump right into it. Let's keep it rolling. The next function that we're going to be graphing here is f of x is equal to negative 9 times 1/3 raised to the x minus 5. So again, we want to list the key features on the left, graph the exponentials using the 3 steps on the right, and actually graph our function. Since we have negative 9 times 1/3 to the x minus 5, we know that there's nothing being added on to the outside of our function. There's nothing that corresponds to the k value for a times b to the x minus h plus k. Since there's nothing there, I know my horizontal asymptote is at y equals 0. Additionally, I can see that the base of my exponential function is 1/3. And if the base is 1/3, that's a number between 0 and 1. So I have exponential decay, which means my graph is going to decrease like a decay function. And it will have this sort of shape. So normally exponential growth looks something like this, kind of. Where it gets closer, that's actually a really bad, really bad sketch. It usually is hovering our asymptote and then shoots up, grows rather quickly. Here we have the opposite, where it's decreasing and then it starts to hover around the asymptote on the right. Again, that's just a key piece of information for me to keep off to the side so that I realize what's going on. I also have negative 9 as my a value. So not only is it going to have a stretch by 9, but it also, that negative is going to give us a reflection. So my graph actually, instead of looking like this, it's going to look like this, because it's going to reflect across the x-axis. So it's going to flip. So it's still going to have that stretch of 9, but it more importantly has the reflection, which means my graph is going to end up having this sort of shape. Now, let's go ahead and actually graph it and see if that's what we get, and kind of give ourselves like a, yeah, that makes sense, or no, not really. So again, we create a little t-chart, x and y, or f of x if you'd rather, and step 1 says to plug in an x so that the exponent equals 0. So my exponent up here, I want this entire thing, something minus 5, to be equal to 0. So what number can I plug in for x? That gives me 0. Exactly, 5. 5 minus 5 gives me 0. So if I choose x is 5, let me actually go down here. F of 5 will then become negative 9 times 1/3 to the 5 minus 5. I'm taking this exact function and plugging in x with 5. This gives me negative 9 times 1/3 to the 0 power. And we know anything raised to the 0 power is 1. So this is negative 9 times 1. So I have negative 9. Cool. And I can plot this point straight away. I've got 5, negative 9. So when x is 5, 1, 2, 3, 4, 5, I'm going to go down negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoa, cutting it close there. 5, negative 9. The next thing we want to do is to plug in an x such that the exponent equals 1. Well, I need some number minus 5 to equal 1. And I know that that will happen if x is 6, because 6 minus 5 equals 1. So f of 6 gives me the following. Negative 9 times 1 over 3 to the 6 minus 1. Again, I'm just plugging in 6 into our original function. 6 minus 1 gives me 1, so I have negative 9 times 1/3 to the first power. That's what we wanted. And we wanted an exponent equal to 1 because anything raised to the first power is just itself. So this is going to be negative 9 times 1/3, or negative 9 divided by 3. And this gives us negative 3. So when x is 6, so we have 1, 2, 3, 4, 5, 6. We have negative 1, negative 2, negative 3. And lastly, we have a horizontal asymptote at y equals 0. So now that I have my horizontal asymptote at y equals 0, I know that my function is going to have to eventually come close to it. I get that my graph kind of looks like this. And it feels a little weird, but it makes sense with the asymptote. Really, there's no other way for this graph to approach it since as x moves to the right, the y values increase, right? This height of this point is lower than this height, and this x value is smaller than the next one over. So I really had no other choice. And based on the fact that it's a decay function and reflected, notice that this weird kind of shape matches with my graph. So that's why having an idea of growth or decay makes sense. Having an idea of what a, h, and k does to your function makes sense for us here. Now, considering that we have a horizontal asymptote at y is equal to 0, I realize that I'm not going to have an x-intercept. I'm never going to be able to touch or cross this x-axis. So there is no x-intercept. The y-intercept, I can't see where it is, but I can solve for the y-intercept. So I'm actually going to erase all this stuff below and show you guys how we can solve for the y-intercept. Now, obviously, looking at this graph, at x is 6, it's -3. At 5, it's -9. It's going to continue to grow pretty aggressively. So I'm assuming, just based on the fact that it's at -9 at 5, it's going to be a pretty large number. But let's actually determine where it's at. So to find a y-intercept, remember, y-intercepts occur when x is 0. So we're going to just set x equal to 0 and solve for y. That would give us when we cross the y-axis. So we're going to have y equals -9 to the 1/3 times 0 minus 5. And 0 minus 5 gives us -5. So I have y equals -9 times 1/3 to the -5 power. Remember, negative exponents just tell us to take the reciprocal, the positive reciprocal, or do the inverse. So instead of dividing by 3 5 times, we're going to multiply by the reciprocal 5 times. So this actually becomes y is equal to -9 to the 3/1 to the +5. I'm going to move this work over here. And 3/1 is just 3. So I really have y is equal to -9 times 3 raised to the 5th power, which is 243. So 243 times -9 is a pretty big negative number. Our y-intercept occurs at -2,187, according to my calculator. So again, my prediction was right. It's going to continue to increase really, really a lot. And then way down here, maybe somewhere, would be the point 0, negative 2187. And that's where our y-intercept is. So although you can't see it and it's not visible on the graph, we can find it. It's 0, negative 2187. And we have our x-intercept, y-intercept, horizontal asymptote. Now it's time to discuss our domain. You notice that we could plug in any number I want to the exponent, and it's just going to give us a really large negative number, right? At 4, it's going to be a little bit larger than negative 9. At 3, 2, 1, 0. And I could continue, and I could even take negative numbers if I really wanted to. I could plug in negative 1 minus 5. Negative 1 minus 5 would be negative 6. So I'd have negative 9 times 1/3 to the negative 6. Again, I would follow this. I would get negative 9 times 1/3 to the positive 3 raised to the 6th power. And I'm just going to get another really big negative number. So my domain, although it looks like my graph is stopping, it's actually continuing to grow and grow and grow on negative infinity. As x continues to go towards the left, my function just is really, 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 really large negative numbers. So my domain is still from negative infinity to positive infinity for exponentials. It's the range that we have to be worried about. The range says, well, what's the height? What's the outputs? What's all possible outputs of this graph or this function? Looking at our graph, we can see that our graph lives below the horizontal asymptote at y equals 0. So my range is going to be everything below the asymptote. So from negative infinity all the way up to the asymptote, since that is literally where my graph exists. And then lastly, we're going to address our end behavior. As x approaches negative infinity, that just means on the left. Where is our function going? What's the y value of my function? And since it's pointing down on the left, it's going to go towards negative infinity. As x approaches positive infinity, just meaning on the right, where's my function going? It's getting horizontal, it's flattening out, it's approaching and getting closer and closer and closer to my asymptote. So my y value, my function's output, is going to the asymptote. Sweet! Let's do one final example, make some sense of it, and test our knowledge. Ready? All right. Remember, at any point in time, you guys, you can pause this video, rewatch, do whatever you need to do, because I know I'm moving kind of quickly. All right, our last and final example for the day is f of x is equal to 5 raised to the x plus 7 power minus 4. Straight away, I have my horizontal asymptote. It's always that vertical shift up and down. So I have y equals negative 4. I know straight away that my base of my exponential function is 5, which means I'm going to have an exponential growth problem. And I know the general shape of a growth problem looks something like that. I don't have a reflection or anything weird to deal with, so I'm going to just leave it at that. Next, I'm going to make my t-chart of x and y, or x and f of x, it really doesn't matter. Again, I want to plug in an x so that the exponent equals 0. So what plus 7 equals 0? Well, easy, negative 7. And the reason I do that is because anything to the 0 power is 1. So 5 to the 0 is 1. 1 minus 4. I actually should do this down here. I think it's helpful. F of negative 7 gives us 5 to the negative 7 plus 7 minus 4. Negative 7 plus 7 is 0, so I have 5 to the 0 minus 4. Anything to the 0 power is 1 minus 4. 1 minus 4 is negative 3. Cool. Next step, plug in x so that the exponent equals 1. What number plus 7 equals 1? That would be negative 6. So I'm going to plug in f of negative 6 just to show you guys. 5 to the negative 6 plus 7 minus 4. Oops. Negative 6 plus 7 does in fact equal 1, so I have 5 to the first power minus 4. And the reason I wanted my exponent to equal 1 is because that's very easy. 5, anything to the first power is itself. So this just gives me 5 minus 4, which equals 1. So given this information, I can plot these points. So x is negative 7, has 1, 2, 3, 4, 5, 6, 7, and down 1, down 2, down 3. Boom. And x is negative 6 is positive 1. I have a asymptote at y is equal to negative 4, so negative 1, negative 2, negative 3, negative 4 gives me this. Oh, girls, close. Horizontal asymptote at y is equal to negative 4. And since it's growth, also, I had no choice but to get really close to my asymptote and grow pretty quickly. So it kind of looks something like that. Maybe it's actually a little bit steeper. I'm not entirely sure. Again, it's just a sketch, but at least I have 2 exact points on my function. I can see from this that it's not clear where my x-intercept is, nor is it clear where my y-intercept is, so I'm going to have to solve for those. I'm going to need to solve for those. So I'm going to do that in the space provided below. These were just showing how I got the output values for my x and y table. So let's find the x-intercept because it comes first, and I can see clearly that it's going to cross my x-intercept. I'm just going to need to solve. So to find an x-intercept, we need to set y equal to 0. So remember, f of x is the same thing as y, so set 0 equal to 5 to the x plus 7 minus 4. And I want to solve for x, the x value. I know y is 0. What's the x value? Where is it crossing the x-axis? So I'm going to add 4 to both sides, so I get 4 equals 5 to the x plus 7. And I need to solve for x. I'm going to have to take log base 5 of both sides to get rid of the 5. So I have log base 5 of 4 on the left equals log base 5 of 5 to the x plus 7 on the right. Doing so leaves me with log base 5 of 4 is equal to x plus 7. But I don't want x plus 7. I just want x. So I have log base 5 of 4 minus 7 equals x. And again, remember our calculators and change of base can tell us exactly what this is. So it's log of 4 divided by log of 5. Remember, base goes on the bottom. This is going to give us about what x is equal to. And I'm going to use my calculator to find log of 4 divided by log of 5. And I get can you see that? 0.86135. And I'm going to subtract 7, so it's a negative number. And that makes sense because it's on the left-hand side. So I end up getting negative 6.14 is about x. And so if I look at my sketch, it's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. That's a little bit past a negative 6. So that makes sense. So my x-intercept, x is negative 6.14, y is 0. To find the y-intercept, it's going to be a pretty similar process. But to find the y-intercept, remember that's where it's crossing the y-axis. It will eventually, it's just going to be a very large one. I'm going to have to set y equal to 0, or plug in y is equal to 0. So here we go. We're going to find the y-intercept now. And to find the y-intercept, we're going to set x equal to 0, because that's where x has no height. So y is equal to 5 raised to the 0 power plus 7 minus 4. Notice I'm just plugging into our f of x function. If I evaluate what this actually is, y equals 5 to the 7th power, 0 plus 7 is 7, minus 4. And I'm just going to use my calculator to figure out what this is. 5 to the 7th is a really big number. Y equals 78125 minus 4. So my y-intercept is huge. Y is equal to 78121. I told you it was going to be big. Because notice, it's already growing so fast. The base of our exponential function is 5. That's really big. So our y-intercept, again, x is 0, and y is 78,121. We can find them, but we certainly cannot graph that. Not on this graph. All right, for exponential functions, we still need to discuss domain, range, and end behavior. So the domain of exponential functions is always negative infinity to positive infinity, because I can plug in any numbers for x. Any input will work. I can plug in negative numbers and get an output closer and closer to my horizontal asymptote. I can plug in positive numbers, large numbers, and I'll just get a large output, a very high output value. So my domain is always negative infinity to positive infinity for exponential functions. I can always plug in numbers. The range, however, depends entirely on where my graph exists. So this graph I can see is above the horizontal asymptote. So my range will be above the horizontal asymptote. The smallest point on this range is going to be my asymptote, -4. So my graph does not begin until -4. It's really, really close to it. And then it continues pointing upwards towards positive infinity. -4 is a smaller number, so it goes first. And lastly, we have to discuss end behavior. On the left, as x approaches negative infinity, where's my function headed? Where's the y value headed? Where's the height headed? And we can see that that's heading towards y equals -4. It's flattening out on the left towards my horizontal asymptote. And as x approaches positive infinity, as x is going towards the right, we can see my function's pointing upwards, meaning that y is approaching positive infinity. So I hope with graphing these things, you feel a little bit more confident in your skills. Get ready, because we're going to continue graphing, but with new functions with logarithms later on this week, and then we will do a bit of review. Have a great day. Remember, you needed to get all these down in your notes. If you need to, you can rewind, rewatch, whatever possible. But hopefully you're feeling better seeing these examples. Bye.